Well, we are going to talk about probability and statistics today. We're just going to do a little bit of it. I think it's really important, but I just want to talk about two things today. So the first thing we're going to talk about is the fundamental counting principle. And what that is just a method of using multiplication to count. Basically, if you have two events, you can multiply them together to figure out possible outcomes. So let's just look at some examples of those. All right, so here we are with example number 1 for the fundamental counting principle. So in 1966, one type of Maryland license plate had 2 letters followed by 4 digits. How many of this type of license plate were possible? So how many options of this type were possible? I think I left it word out. So all you do is there are 2 letters and 4 digits or 4 numbers. So if you multiply those together, you get 8. So there are 8 possible outcomes of options. Okay, so let's look at example 2. We have 5 chicken options and 6 side options. If each dinner consists of 1 chicken option and 1 side, how many different dinners are possible? So we have 5 chicken options, so that's 5 times the number of sides. So 5 times 6 is 30. So there's 30 combinations of dinners are available. So you have 30 different options of those of dinner with those options. All right, so example 3, if I have 10 different bag options and 7 different shoe options, how many bag and shoe combinations do I have? So we have 10 bags times 7 shoes, so that's going to be 70 combinations of bags and shoes you could wear. All right, and that is pretty much it on the fundamental counting principle. So next we will talk about experimental probability. Okay, so experimental probability is, so you take, like if you want to find the experimental probability of an event, you just take the number of times the event occurs or has occurred and divide it by the total number of trials. So here's an example of 60 vehicles in the parking lot. Today, 15 are brand new. What is the experimental probability that a vehicle in the lot is brand new? So the probability that the vehicle is brand new is going to be equal to the number of brand new vehicles divided by the number of total vehicles. So there are 15 brand new vehicles. So that'll be our number on top. And then we divide that by the total amount of vehicles, which is 60. When you do, you get 0.25, which is 25%. To change decimal to a percentage, you just move your decimal 2 places over to the right, and then that's what makes 25%. Okay, so let's look at example 1 for experimental probability. So what is the experimental probability that a basketball player will make his next dunk if he has completed 12 of his last 23 attempts? So the probability that he will make a dunk is the number of times he has completed the dunk. So that's going to be 12 divided by the number of attempts, 23 attempts. So in your calculator, you just put 12 divided by 23, and when you do, you'll get a decimal like that, something like that. So you want to move your decimal 2 places to the right, and this is 52.2%. So when you move your decimal over, I want you just to round to the tens place. So that's 1 place past the decimal. And so like 52.2%, like what does that mean? That's almost half, right? 50% is half, so he makes it a little bit more than half the time. Okay, so let's look at example 2. A shuffled 52 card deck. There are 12 face cards. What is the experimental probability that you will draw a face card next? So the probability that you'll draw a face card is equal to the number of face cards divided by the total number of cards. So in your calculator, you just do 12 divided by 52. And when you do, you will get 0.2308. Wait, it keeps going. It's a long decimal. So you'll move your decimal 2 places to the right. And when you do that, it's 23.1%. That 0.8, this will go up to, it'll round up to 1 because 8 is bigger than 5 right there. Okay? All right, so let's look at example 3. Out of 74 attempts, 62 goals were made. What is the experimental probability that the next goal will be made? So the probability of making a goal is, how many were made? 62. So it's equal to 62 out of the total number of attempts. So out of 74. So 62 divided by 74 is 0.837837, and the 837 just repeats. Move your decimal 2 places to the right, and that is 0.78. So the 7 will round up because 8 is greater than 5. So 83.8%. So there's a very good chance that the next goal will be made. And that is all for today. Thank you all very much for bearing with me. Let me know if you have any questions.